Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss the iteration method. First, in this method, we find the interval in which the root lies. For that, we use the intermediate value theorem. The iteration method is one such method which requires one starting value of x. We can use this method if we can express f of x is equal to 0 as x is equal to phi of x. That is, write the given equation as x is equal to something. Okay. The above form we can express in more than one way also. For example, we have the equation x cubed plus x square minus 1 is equal to 0 can be expressed in the following ways. See, x cubed plus x square minus 1. If you take x square is common here, x square is common here, x is remaining, and put this minus 1 in right hand side, it becomes plus 1. That is x square is equal to 1 upon x plus 1. Otherwise, write 1 upon 1 plus x. X plus 1 and 1 plus x, both are the same. Addition is commuted. Now we want x is equal to. So taking square root both sides, that is we get 1 upon under root 1 plus x. That is 1 plus x raised to minus 1 by 2. Otherwise, we can write also x square. Put minus 1 and x cube in right hand side. 1 minus x cube. That is x is equal to, taking square root both sides, 1 minus x raised to 3. Okay. Otherwise, 1 minus x raised to 3 raised to 1 by 2. Okay. There's one more possibility. We can write x cube is equal to 1 minus x square. That is x is equal to 1 minus x square. Take 1/3 power both sides. Okay. That is x is equal to 1 minus x square raised to 1 by 3. In this way, we express this f of x in 3 ways. Okay. Those we just discussed. Now here question is which equation we should select here. So for that, we use the condition here. Now this is the phi function. These are the phi function, phi of x. Now differentiate this phi function. Differentiate the right hand equation with respect to x, that is phi dash. Okay, phi dash x. If the magnitude of this phi dash x is less than 1, then select phi function. Then select the x is equal to phi for the iteration method. If not, then reject the phi. Okay. And here after getting the value of phi dash is less than 1, then the next step is first iteration. For first iteration, we choose the x naught. Okay. So here, this x belongs to interval, and we find this interval by using intermediate value theorem. Okay. Now for all value of the x, the phi dash is less than 1. Now selection of x naught belongs to this interval. Okay, the x naught from the interval. Interval is as like a comma b. Close interval a comma b. Now let us see. First we take the x naught, be approximation, okay, to the desired root. Now substituting x naught in a right hand side of equation 1. So we get the first approximation as a x1 is equal to, say, equation number 2. Now the successive approximation are given by x2 is equal to phi of x1, x3 is equal to phi of, here we can write next approximation x3 is equal to phi of x1. Okay, the process is very simple. After identify phi function, then choose the x naught. Choose the x naught. X naught belongs to the interval. Okay, and put x naught in the phi function. We get the first iteration as a x1. Okay, now x1 put in again in phi function, we get x2. Similarly, we get the x3. X3 is equal to phi of x2. Phi of x2. Okay, in this way, the nth iteration is xn is equal to phi of x suffix n minus 1. And the sequence of approximation x1, x2, xn convergence to the root zeta. Okay. Sequence of approximation x1, x2, xn convergence to the desired root zeta in the interval I. But when phi dash is less than, magnitude of phi dash is less than 1 for all x in I. So this is the condition. Now let us see the example on the iteration method. Use iteration method to find the correct 4 significant figure, a real root of the equation x cube plus x minus 5 is equal to 0. Now here the function is given f of x is equal to x cube plus x minus 5 is equal to 0. Say equation 1. Okay. So before proceed, see here in the problem, the interval is not given. So first we identify the interval and then we choose the x naught. Okay. So here we use trial method. First we put the 0. We start from the 0 here. Put x is equal to 0. Then we get minus 5. Here 0, 0, minus 5. Then put x is equal to 1. X is equal to 1. Then we get 1, 2. That is we get the again minus sign. Okay. Now put x is equal to 2. That is 2 cube is 8 plus 2 minus 5. So we get here 5. So here see, we get the opposite sign. Opposite sign, it means root lies between 1 and 2. Okay. That is the interval is 1, 2. Okay. Now we got the interval. Now we find the equation for iteration method. We find the equation x is equal to phi of x. Let us find x is equal to phi of x from equation 1. From equation 1. Now here we have the two possibility. We have 3 possibility. So first possibility is here. We can write from equation 1. We can write. See, we have the equation x cube plus x minus 5 is equal to 0. X is equal to put minus 5 on right hand side and minus x raised to 3. So here we get 5 is equal to 5 minus x raised to 3. What happens if we differentiate this? Then phi dash is equal to minus 3x square. Okay. And when we put the value of the x as a 1 and here minus 3, and when we take its mod, then we get the 3 and which is not less than 1. So this selection is rejected. Okay. Now the next, we write x cube is equal to 5 minus x. It can be written as taking 1/3 power, x is equal to 5 minus x raised to 1/3. Now this is the phi. Phi is equal to 5 minus x raised to 1 by 3. Now differentiate, then we get 5 dash is equal to 1 by 3. Okay. 5 minus x, derivative of the function f raised to n is n, f raised to n minus 1. That is 1 by 3 minus 1. 1 by 3 minus 1. So we get what? Minus 2 by 3. Again, derivative of the bracket is minus. That is the simplified term is minus 1 upon 3, 5 minus raised to 2 by 3. Okay. We write here as a raised to minus 1 is 1 upon a. In this way, we write this term. Okay. Now here, this is the 5 dash. When we put x is equal to 1, x is equal to 1, that is here 4. 5 minus 1 is 4. Raised to 2, okay, that is 16 and it's 1/3 power. So definitely we get the some non-zero number and into 3. Into 3. The denominator is larger the numerator. Okay, and when we take its magnitude, definitely we get the less than 1. When we put highest value, 5 minus 2, that is 3, take its square and then 1/3 power into 3. Okay, and when we take its mod, then we get the less than 1. So this is the correct value for the phi function. So here x is equal to, from equation 1, we select x is equal to 5 minus x raised to 1 by 3. Okay, that is phi function is 5 minus x raised to 1 by 3. Okay, what is the general formula? Xn is equal to phi of xn minus 1. It can be written as xn 5 minus, put x is instead of x, put x suffix n minus 1. Okay, raised to 1 by 3, comma, n is equal to 1, 2, 3, and so on. Say question number 2. Now, when we put n is equal to 1 here, then here x naught. And we want x naught here. The x naught we select from the interval. Here we select first x naught, which is depend on us. That is, we select the x naught between 1 and 2. X naught we select as a 1.5. Okay, it should be belongs to the interval I. Okay, now put n is equal to 1 in equation number 2. Then first iteration x1 is equal to 5 minus x naught raised to 1 by 3 is equal to 5 minus 1.5 raised to 1 by 3 is equal to. Now using the scientific calculation, we find the value 5 minus, just wait, 5 minus x 1 by 3. X is 1.5. we get 1.5182944486. Okay, this is the first approximate value. Now next, put n is equal to 2 here in equation 2. Now x2 is equal to 5 minus x1 raised to 1 by 3. That is 5 minus the value of x1 we have calculated here, 1.5182944486 raised to 1 by 3. Okay, using the calci, we get x2 is equal to just wait, 5 minus 1.5182944486. We get 1.5156 44449. This is the x2. Now next iteration, x3 is equal to 5 minus x2 raised to 1 by 3. How we get x3? In equation 2, we put en is equal to 3 here. Okay. Now we have the x2. Now substitute the x2 here. That is 5 minus the value of x2 is 1.5156 44449. So we get x3 is equal to 1.51602892. Okay, now next iteration, x4 is equal to 5 minus x3 raised to 1 by 3 is equal to here raised to 1 by 3. 5 minus the value of the x3, 1.51602892 raised to 1 by 3. So we get x suffix 4. Okay, that is the fourth iteration. 1.5159. Yes, better 1.515973.165. Okay, now we stop here. We just perform the 4 iteration here. Now the question is, use iteration method to find the correct to 4 significant figure. 4 significant figure, that is 1, 2, 3, 4. Okay, and here this is the 9. So we round up here. That is the required answer is x4 is equal to 1.516. Now next question, use iteration method. Second question, use iteration method to find real root of equation x cube plus x square minus 1, which lies in the interval 0, 1. So here interval is provided. Okay, and perform the 3 iteration. Perform 3 iteration. Okay, first we write the function let f of x is equal to x cube plus x square minus 1 is equal to 0. Now here interval already given. Okay. If not given, then put x is equal to 0, x is equal to 1. In first problem, first we identify the interval. Okay. So here interval is given. We select the x naught directly. The value of the x naught we choose. Let x naught is equal to the value it should be belongs to the interval 0, 1. It may be a 0, it may be a 0.1, 2, 3, 4 up to 1. Now here I am selecting 0.6. Okay. Now for iteration method, we want the equation 1 as a x is equal to. For iteration method required x is equal to phi of x. Now in the initial stage of the video, we already discussed the same equation x cube plus x square minus 1. So here we get the three equation for x is equal to. Let us see. Now see, x is equal to 1 plus x raised to minus 1 by 2. X is equal to 1 minus x raised to 3 raised to 1 by 2. 1 minus x square bracket raised to 1 by 3. Now last two equation, if we differentiate, okay, then 1 by 2 is here and 1 by 2 raised to minus 1, and again derivative of this bracket. When we differentiate again, then here 3x square is here, that is 3 is there. Similarly here, when we again differentiate, then 2x square, the derivative of x square is 2x, 2 is there. And when we put the value of the interval, then we don't get the value of phi dash is less than 1. Now for the first possibility, when we differentiate, see, we select the first possibility as a x is equal to, we ignore the remaining two possibility, x is equal to 1 plus x raised to minus 1 by 2. Now this is the phi function. This is phi of x, that is phi x is equal to 1 plus x raised to minus 1 by 2. Now differentiate, phi dash x is equal to, the derivative of the function is 1 by 2 minus 1 by 2, 1 plus x raised to, here derivative of f raised to n is n, f raised to n minus 1, again derivative of function. Okay. Now here minus 1 by 2 minus 1 minus 3 by 2, again derivative of 1 plus x is 1. Okay. Now simplify, then we get minus 1 upon 2, 1 plus x raised to 3 by 2. Okay. Now here the lowest value of the interval, here interval is 0, 1 is 0. When we put 0 here, 0 plus 1 is 1, 1 into 2, that is 2, minus 1 by 2, when we take its mod, then we get the less than 1. Similarly, for highest value, when we put x is equal to 1, x is equal to 1, 1 plus 1 is 2, 2 raised to 3 is 8 and its square root. Okay, which is definitely 2 raised to 3 means greater than 2, and this 2 into 2 means definitely the value is greater than 4. Okay, and minus 1 upon this value. This is the large value than numerator, which is greater than, this value is greater than the numerator value, then definitely when we take its mod, then we get the less than, that is phi dash x is less than 1 for all x. Okay. Now, first we write the general formula. It can be written as x suffix n is equal to phi of x suffix n minus 1. X suffix n is equal to, the phi function is 1 plus x raised to minus 1 by 2. So here write suffix n minus 1. N minus 1 n is equal to 1, 2, 3 and so on. Now put n is equal to 1 here. Then the first iteration is x1 is equal to 1 plus x naught raised to minus 1 by 2. Okay, is equal to 1 plus the value of x naught we have already selected, that is 0.6. This value you can select 0, 0.1, 0.2, okay, up to 1. Now here we have selected 0.6. 0.6 raised to minus 1 by 2. We get the first value, x1 is equal to, x1 is equal to, just wait, through calculating we get 0.7905694 1504. This is the value of x1. Now the next iteration, x2 is equal to, put n is equal to, suppose this is the equation number 2. Put n is equal to 2 here. Put n equal to 2, then we get 1 plus 2 minus 1 is 1. X suffix 1 79. The value of x1 we have calculated here, 0.56941504 raised to minus 1 by 2. We get x2 is equal to 0.74731623821. Okay. Now the last iteration, x3 is equal to, put n equal to 3 here, 1 plus x2 raised to minus 1 by 2. x2 is calculated here, 1 plus 0.7473 1623821. So we get x3 is equal to 0.75650925163. Okay. Now the question only for the 3 iteration. Perform the only 3 iteration. Now, if we want the correct this value up for 4 significant digit, then count the 4 significant digit, 1, 2, 3, 4. Okay. And the 5th place is less than 4, less than 5. Okay. Then keep the number as it is. x3 is equal to 0.75 0.7565. Okay, which is required answer. Now the next problem, find the root of the equation 2x minus cos x minus 3 is equal to 0, x naught is equal to pi by 2, and perform only 2 iterations. So first we write the equation f of x is equal to 2x minus cos x minus 3 is equal to 0, and we write this equation 1 as x is equal to 5. We write the equation x is equal to, for that we put minus cos and minus 3 in right hand side, and the 2 is divided. So we get 5. Now differentiate. After differentiating, the derivative of cos is minus, the derivative of 3 is 0. So we get minus sin x upon 2. And when we take its magnitude, the mod of sin x is less than or is equal to 1 and divide by 2. Okay. So the value of the numerator is less than or is equal to 1 and divide by the 2. So for all value of the x, okay, when we take its mod, when we take the mod, then we get definitely the value is strictly less than 1. That is 5 function is correct. So we make it generalized. Here we write the x suffix n, and here put x is equal to x suffix n minus 1 and put n equal to 1, 2, 3. So put n is equal to 1 here. X suffix 1 is equal to cos of x naught plus 3 divided by 2. And x naught is given. X naught is given. Substitute the x naught here. X naught is pi by 2. Then cos pi by 2 is 0. 3 by 2. Okay, 3 by 2 means 1.5. We get the x1. Now the second iteration, put n is equal to 2 here. Then x2 and 2 minus 1, 1. Cos of x1 plus 3 divided by 2. Put value of x1 is 1.5. Through calculation we get 0.9996 plus 3 divided by 2. Okay, simplify. Then we get x2 is 1.9998, which is required answer. Okay, which is required root after perform the second iteration. Thank you. Thank you for watching.